Still on rational functions, but we're talking about wholes and vertical asymptotes. We did the horizontal asymptotes. Those were the ones that had the three cases. And then we did the zeros yesterday. Zeros are the x-intercepts. That's where the numerator is set equal to 0. So a hole in the graph occurs when a factor in the numerator cancels out with a factor in the denominator. So when you have the numerator and denominator factored, if you have the same thing, you have an x plus 3 on the top and an x plus 3 in the bottom, when those cancel out, that's where you have a hole. What you do is you set that factor equal to 0 and solve. Now when you do that, that will just give you the x value. Sometimes you will see that it might say there's a hole at x equals 2. Or you might see a hole at, and it might give you a coordinate like 2, 3. This was what I actually saw on the Precal Facebook group. Somebody posted, which way are we supposed to have our students do it? Some people said, just have them put x equals the number. Some people say the coordinate. So we're going to do both. We'll practice doing the coordinate just because that just takes it one extra step. So if you have the x value, now if you have multiple choice and it has like x equals a number, then you can just stop there. But if you need the whole coordinate, what you do is you plug the x value back in to the simplified function to find the y value. And I'll show you an example of that. So I have this example, this rational function, where the x minus 1s cancel. So if that cancels, that just leaves me with x plus 2 over 1, or just x plus 2. Okay. So if I have my x minus 1 equals 0, x equals what? 1, right? So I have a hole on my function where the x value is 1. Now, if you have to put a coordinate down, what you do is you just look back at, this is the simplified function. So after you've canceled something out, I just plug that x back in. 1 plus 2 is what? 3. So I have a hole at the point 1, 3. And then the other thing that we're going to do is vertical asymptotes. So a vertical asymptote occurs at any of the factors left over in the denominator. So after this is out. So whenever you cancel out any factors, those are your holes. Anything left over in the denominator, that tells you where your vertical asymptote is. So you set that factor equal to 0 and solve. So for example, I could cancel out the x plus 2's. So I would have a hole at negative 2, but my vertical asymptote, I do x minus 1 equals 0, x equals 1. So my vertical asymptote is at x equals 1. And that's all we're doing today. So number 1, this is already factored. I have a 3 on the top, x plus 4, x minus 10 on the bottom. Does anything cancel? No. If nothing cancels, then there are no holes. So your vertical asymptotes, I'm going to have 2 because I have 2 factors left over in the bottom. I'll do x plus 4 equals 0, which gives me x equals -4. And x minus 10 equals 0, which gives me x equals 10.
Do you have Ben Brown and Daisy Wayne? Daisy's not here. Okay, Ben can talk to you just like super quick.
All right, number 2, our x plus 2's cancel. So I'm going to set x plus 2 equal to 0. And so x equals -2. Now when I cancel those out, I'm left with x minus 9 over x plus 4. So I'm going to need to plug that -2 back in to get my y value. Again, holes, sometimes you'll see it stop. Sometimes you'll see x equals -2. Sometimes you'll see the coordinate. So we're going to practice doing both. So if I go back to my function, so after I've canceled out the x plus 2's, I've got my y is going to be -2 minus 9 over -2 plus 4. Which is -11 over 2. So my hole is the point -2, -11 over 2. Decimals are okay. If you change that to -5.5, I would say all of the time leave it as a fraction. I mean, it's easier to leave that as a fraction, really. Vertical asymptotes. There was only one factor left over in the denominator after we canceled out. So I'm just going to set the x plus 4 equal to 0. Which gives me x equals -4. Any questions? Number 3. Something that's different about this one is that's squared. That's the same thing as having x minus 8, x plus 2, x plus 2. It's the same thing as having the x plus 2 twice. When you have a squared, that means you multiply it by itself. The reason that I wanted to write it out that way is because when I cancel an x plus 2, it only cancels with one of them. There's still another x plus 2 left in the numerator. So when you see that squared, that is something that you need to think about. So I only canceled out one thing. So my wholes I've got x equals -2. To find that y value, I need to plug in -2 back into my function. So -2 minus 8 is -10. -2 plus 2 is 0. Look, what's -10 times 0? 0. If I take 0 divided by anything, what am I going to get? 0. So you could finish this out, but I know that it's going to be 0. I mean, I could do -2, -3, but it's still going to be equal to 0. Vertical asymptote. We have two factors left in the denominator. We have x that's by itself, so you just put x equals 0. And that's it. X equals 0. And then x minus 1 equals 0. So x equals 1. Any questions? Now you can, did we have so you can have more than one whole. We've not had any of those yet. But if you have two things that cancel, you would set both of those equal to 0 and plug both of those numbers back in separately. I don't know if any of these examples do that or not. Now starting with number 4, things aren't factored. So we have to factor it first. So x squared plus x minus 12. We need two numbers that multiply to be -12 but add to be 1. What are those two numbers?
4 and -3.
Yes. X plus 4, x minus 3. And then two numbers that multiply to be 8 and add to be 6. 4 and 2. X plus 4, x plus 2. So my x plus 4s cancel. So I have whole where x plus 4 equals 0. So my x is -4. And then to find my y value, I plug that back in. -4 minus 3 is -7. -4 plus 2 is -2. I would not leave that as -7 over -2. I would cancel out the negatives and make it 7/2. This type of calculation, you should be doing that without a calculator. I mean, I'm not going to count off right now if you use a calculator or not, but on the AP exam, I'm guessing this would be a non-calculator type question. So we have a whole at -4, 7/2. Okay. Vertical asymptote. The only thing left over in the denominator was x plus 2. Set that equal to 0. And we get x equals negative 2. Number 5. Two numbers that multiply to be negative 15 and add to be negative 2. Yep, x plus 5 and x minus 3 is how that factors 5 and negative 3. X squared minus 9, what is that? Yeah, it's a difference of squares, so it factors into x plus 3, x minus 3. Yeah. So my x minus 3's cancel. I don't expect to see you write x minus 3 equals 0. If you want to just put x equals 3, that's fine. My y, 3, if I go back to what's left over, 3 plus 5 is 8, 3 plus 3 is 6. That simplifies to 4 over 3. So we have a whole at 3 4/3. And a vertical asymptote. I look at my factor that's left over in the denominator, x plus 3. If I set that equal to 0, I get x equals negative 3. Number 6. I need two numbers that multiply to be negative 6 and add to be negative 1. Negative 3 and 2. So x minus 3, x plus 2. Now when you see that denominator, you are probably going to think, oh no, I need the box method, because there's a number in front of the x squared. But you actually don't. Do you see how all three of those numbers are divisible by 3? We can get out that GCF. Okay. So you can factor out a GCF, which is very likely that you would have to do on a test question. And then what's left over doesn't have a number in front of the x squared. What numbers multiply to be 3 and add to be 4? 3 and 1. So this is, I still have the 3 in the front. And then I have x plus 3, x plus 1. Okay. Does anything cancel? Nothing cancels. So there's no holes. And then vertical asymptotes, that's just a plain 3. There's no x with it, so you don't need to set that equal to 0. Only the parts that have x's with them. So I have an x plus 3 equals 0. So x equals negative 3. And an x plus 1 equals 0. So x equals negative 1. Any questions? Number 7. I need two numbers that multiply to be -6 but add to be +1. +3 and -2. All right, now this denominator, it has a GCF. So it's not a difference of squares right now, because to be a perfect square, a variable needs an even exponent. But it has a GCF. Okay, so if I factor out an x, I'm left with x squared minus 4. What's special about x squared minus 4? That's a difference of squares. So we have the x, that was our GCF. And then how do the difference of squares simplify? X plus 2, x minus 2. Good. So my x minus 2's cancel. So my x value for that whole is a +2. And then for the y value, I have to plug that 2 back in. 2 plus 3 is 5. And then I have a 2. And a 2 plus 2 is 4. So my y value would be 5/8. So I have a whole at the point 2 5/8. And then vertical asymptotes. I have two things left over in the denominator, an x and an x plus 2. Set both of those equal to 0. The x equals 0. And then if I do x plus 2 equals 0, I would get x equals -2. Any questions on that one? All right, last one. Number 8. The numerator has a GCF. They all have an x in common. So I'm going to factor out the x. And then two numbers, we've already actually done this one, that multiply to be 8 and add to be 6. We said were 4 and 2. So x plus 4, x plus 2. And then the denominator also has a GCF of x. When I factor that out, I'm left with x squared minus 1. What's special about x squared minus 1? It's a difference of squares. 1 is a perfect square. 1 times 1 is 1. So that one factors into x plus 1, x minus 1. Do any factors cancel out on this one? The x. They both have a plain x, so those cancel. We would have a hole at x equals 0. And then for the y value, we just plug a 0 back in. 0 plus 4 is 4. 0 plus 2 is 2. 1 and negative 1. That gives me 8 over negative 1. So I have a hole at the point 0, negative 8. And then vertical asymptotes. We have 2 factors left over in the denominator. I would have a vertical asymptote at x equals negative 1 and a vertical asymptote at x equals positive 1.